Эффективное использование и безопасность на участке ГРП. Автоматизированный участок ГРП. Чат Ван Buskirk. Так, связь у нас там подключена на первый доклад. Вырубайте тогда.
Thank you very much. Thank you very much, everybody. I'd
Так,
like
слышно,
to
связь
introduce
есть?
myself. Thank you very much.
Все, пожалуйста. Please.
Thank you very much, everybody. And depending on what time zone you are in, good evening or good morning. My name is Chad Van Buskirk. I am an innovation subject matter expert with Intelligent Wellhead Systems. I'm a professional engineer. I have my certification with the SPE, and I'm a certified petroleum data analyst. I'll be talking to you today about where we're at with automating the frac site by enabling critical technologies. I'd like to offer anyone the paper in the background after the conference. If you can contact me directly, my contact information will be on the last slide. So if we look at other industries, we see automation happening all the time. In the fracturing industry, we want to use automation in a stepwise process as a tool. So we're looking at ideal candidates to automate, and we're looking at human-caused incidences that are ideal for engineered controls. Now we look at situations where we have accidental shut-ins on active wireline on a plug and perf operation. We look at accidental shut-ins on a frac operation, leading to high pressure, overpressure events. We're looking at accidental valve actuations or valve openings that lead to pressure releases. Now, all of these processes are during a complex well swap operation, perhaps, but they have standard operating procedures that kind of guide the field crew on these standard and repeatable sequences. So these are ideal candidates to automate. And as we all know, the consequences can be severe for getting this wrong on a fracturing site. You could have wireline recovery operations. You could have an interruption in your schedule. Maybe you have a stage plan that depends on you going from well to well in an operational sequence, and that is interrupted. You could, of course, have a catastrophic safety event with pressure. You could have severe equipment damage. Power ends could be damaged during a high pressure event, leading to concerns in equipment and cost, of course. And of course, you could have non-productive time, and your AFE could be overrun. Again, high cost. And something we always think about is time to first production of the well, that could be delayed. Now, if we look at a fracturing site, we see some challenges that might be unique to a fracturing site. So in North America and around the world, a plug and perf fracturing site has inconsistent site layouts. You have inconsistent environments, as in temperature, weather. We have inconsistent equipment, different configurations on manifolds on the ground, even standing iron in some case, to different vendors using different types of equipment, different models, different legacy equipment out there. And we have inconsistent SOPs, so standard operating procedures that companies and operators would have developed to keep things safe. They're not always the same, and wellhead configurations are not always the same. We have inconsistent data formats out there, inconsistent hardware to deliver these this data. And what we can consider these sites to be is a temporary plant site. When the fracturing crew leaves, sometimes it's like they were never there. Remoteness and connectivity issues, that's always a problem with remote sites in the oil field. And we have ways of dealing with that to deliver information now. And if you can imagine We're already seeing hundreds and maybe even thousands of sensors on site. It's only going to increase in the future. So at IWS, we see 3 levels of automation, and there's 3 levels that the industry is currently in. So this is not autonomy per se, but automating tasks and processes on site. So the first level would be that data aggregation and surveillance of your site. So what we're doing there is bringing in all the services data, various services that might be traditionally siloed in their own systems, and bringing them to one time synchronous format. What we're also doing is traditionally the wellheads had no digital outputs. We are digitally twinning those wellheads, enabling the ability to confirm key items for automation. And this data is typically retrieved via sensors, industrial sensors, physical cables, and cloud solutions. These are then aggregated using edge servers or cloud capabilities. Now we move on from that first level, which is pretty prominent in the industry right now, to a second level of automation. And that's where we start to use that data that we're aggregating to automate administrative tasks. So anything that is mundane and repetitive in data entry or analytics, these processes can start to be automated. Now we're seeing this done in live data coming from fracturing sites. We're also seeing this done in past jobs, maybe going back 3 years for an operator. And what we're doing is translating that into industry recognized formatting standards. The IPDS being a great example, International Petroleum Data Standards. Now, once you have that trustworthy data, you can start to transform it and transact it and store it to other enterprise software or other vendors. So you can start to move via API, application programming interfaces, to well site reporting systems, for example. So what you're doing there is limiting the time spent entering data, formatting data, moving data, cleaning data. You're trying to get a consistent, trustworthy data stream filling your database. And this third level of automation, this is what we get into with my group, is using this information to now start to deliver controls to site, automating physical processes. So what we do is control valves and equipment using vital components on site. And this will be a vital component of the autonomous frac site in the future. So what we're doing is we're leaping past that theme where we're just watching what's happening, and we're using the information now to feed back through logic checks to the site to initiate physical barriers from human error happening or anything that we can automate that might help on site. You can even think of a car, a new age car, where if your car is in drive and you're speeding down the road, you can't activate your trunk or hatch. These are nice logic checks that we can use that kind of same theme on a fracturing site. So what we're doing is we're engineering out human error. Despite all of the surveillance we have out there and screens and alarms, unfortunately, we still have that valve that can be swung, that valve that can be closed during inopportune times and cause events. So what we are doing is we're creating a human barrier for control. We call them hydraulic interlocks at the accumulator itself. So even if an operator walks up to that accumulator bank, wants to operate the wrong valve, there's a physical impediment in his way not to actuate that valve. So what we do is we started a project that initiated based on proprietary technology, and it worked on the basis of trust and control checks. So what we do is we rely on each component. So trust in each component relies on the trust of the previous component in order to proceed. And that is a typical logic check sequence in any kind of control system. So what is our first control check on a plug-and perf fracturing site? We have a proprietary tool that uses a sensory array, or an array of sensors, that avoids you having to guess whether the tool, the wireline tool, even coiled tubing, is clear of the injector, of the lubricator, of the wellhead. So you're getting a digital window inside of the pipe. So this is validating for you that you can close the crown or swab valve after we go through a few more logic checks. You can see here, this is a human-machine interface on site that delivers a good visual, accurate visual to operators that the tool is indeed out of hole or is in hole. Our control check 2 is a physical barrier via a triple handshake, a digital handshake where operators have to enter a code into an interface on site, tablets that are distributed along site and connected via a local network. So the triple handshake happens between the wireline operator, in this case, the valve operator, and the well site manager. When we apply some logic controls here, you can see half of a logic control here. The well activity is identified to be wireline from the state of the operation inputs coming into the system. Does control check 1 identify tool in hole? Yes or no? If it's a no, we can actually disengage that hydraulic physical lock at the accumulator valves. If it's a yes, we need to go back to that digital window and control check 1 and verify that it is not through that valve. This is where we want to operate the crown or swab valve on top of your wellhead stack. You can see here, these are pieces of equipment that can be installed onto any accumulator bank, bolted on. And at the end here, a physical punch comes out that does not allow a valve to operate back to the open position. Control check 3. So now we're looking at valve actuation and position of valves, and we're verifying those through a check. Right here, you can see a valve position sensor installed on maybe a master valve here. What we do here is we convert the physical equipment into a digital twin. And on this human machine interface, depending if you're the wireline operator or the frac supervisor or the well site manager or someone at the accumulator bank, you will have a visual of closed valves if that well is on frac, if you're on wireline, open valves in green, plus a red dot for every valve that signifies you cannot physically operate that valve until you enter the codes for your digital handshake. Control check 4. So now we're empowering our real-time controls and dashboarding by a trustworthy site-driven being the key term there, operations data. So not only can we start to initiate feedback loops and controls on physical equipment, we can start to gather that great data from site from all services that can start to build information blocks and turn into nice visuals for dashboards. We can start to automate ISIP calculations. We can give visuals on every well of wireline versus pump down speeds on one graph. We can give all types of operational analytics. And we can start to develop those reports and the data analysis that comes with a lot of the post-pad operations in offices, let's say. So in this fourth control check, we've enabled the hub. And here's a good visual of our container. We're very modular. We can get on site and deploy anywhere. And we're very versatile on which kind of equipment we can connect to. We haven't had any stumbling blocks yet in that respect. So the results and conclusions, we've been commercialized for 2 years. This technology proves a valuable first step, and we rely on those trust checks, control checks, to make sure we're doing things right. We cannot hand over the controls to a logic check or a machine until we get that right and have the checks in place. We look at valve sequencing during a well swap. That's a complex operation that has standard and repeatable operations. So we're looking at well swap times on a plug and perf site coming from 30 minutes, let's say, down to less than 5 minutes per well swap. And those are all digitally verified and checked by those 3 handshakes. And we're as low as 2 minutes in some case. And it's key here that since the technology was implemented 2 years ago, we have not had one customer that has had a single shut-in on wireline, mistaken valve closure, or overpressure event. And again, as I mentioned at the beginning, thank you. I'll take any questions, and the paper is available to anyone that wants to contact me.
Спасибо. Какие-нибудь вопросы?
Thank you. Any questions at this point?
Thank you very much.
We don't have any, it seems. So
Переходим
thank you
тогда
for the
к
presentation.
следующему
And we'll move
докладу.
over to the next one.
Доклад тоже онлайн. Тема его «Забойные двигатели для калцубинга». Читает Лукьянов
Okay,
Денис Александрович, менеджер по развитию бизнеса Шорер и Блэкмен Россия. Так, связь есть у нас? Связь есть, слышимость? Да, хорошо слышно. Денис, пожалуйста.
Good afternoon, dear colleagues. Denis Lukyanov from Schellenberg. From Schellenberg, Darren. I've been working with bottom hole motors all my life. And we've been trying to use the motors most efficiently and trying to root out any problems that our clients might have when running the downhole equipment. Well, the downhole motor is a quite complicated and comprehensive tool. And whenever you're running them on a coil tube, you might run into aggressive fluids such as diesel, crude oil, nitrogen, or different acid solutions. Also, whenever you're using the downhole motor, you might also run into high bottom hole temperatures, such as 160 degrees centigrade and higher, and also you might have extended reach with substantial inclination and substantial angles. During milling, when using the downhole motor, there are 2 factors to take into account. First of all, that is the first and most vulnerable element of the bottom hole motor, which is the use of aggressive flushing fluids, which might lead, fluids that might lead to swelling of the elastometer. And the most often cases are illustrated here, the swelling, also degradation of the glue between resin and metal, and bubbling and bloating after the contact with nitrogen. The second important factor that I mentioned was the high bottom hole temperature that leads to self-heating of the stator teeth and their deterioration because of the high hysteresis. which is the extended development of the highly elastic deformation. I have the thermal and heat distribution in the stator resin. This is how the deficiency appears, how it develops, and how the crack materializes, leading to the resin failure. To minimize the negative impacts that I've just mentioned, to compensate and offset these damages, we have developed this Spirostar technology. It's called SAS for short. We're using the profile stator with the even thickness of the resin coating. Many hunters know this technology. This is how the boars were rifled, for the hunting rifles. In the Spirostar, the rifles are also metal, as you see, and it's metal that is resin coated, which minimizes its swelling as a result of the high temperature, which is achieved by better heat distribution. We're using high quality HMBR rubber, which makes it resilient to aggressive environments. The second important benefit of using the Spirostar motor is that it has better performance. It has better torque and better power output. And high pressure changes, the resin, which is elastic, gets deformed, and there can be partial overflow of the fluid between the rotor and the stator without any performance up to the downtime of the downhole motor. By using the Spirostar in combination with metal teeth and rubber coating, the overflow possibility is minimized, which means that it's able to operate at higher torque and with higher power. The Spirostar motors are available in the 4 typical sizes and gauges. Whenever we need to perform additional operations and to prevent it from damage, we suggest using the circular connector PBL, which drops the ball and isolates the lower segment and allows pumping fluid through the ports into the annulus. Using the balls, you're able to divert the flow back into the tube and perform further milling operations. As we see from the slides, we also see the available gauges on the slide. The PBL also enables washing out the strings, paraffins, sand, and other debris, because in many cases it's impossible to ensure the washout rate because of the limitations imposed by the flow rate restrictions in the annulus. The combination of PBL plus the bottom hole motor might reduce the number of trips, therefore reducing the wear and fatigue of the string and reducing the time frame of the bottom hole operations and well interventions. We have 2 successful cases of combination of the bottom hole motor with the PBL in Eagle Ford, USA, and in southern Texas. We've been pumping acid using the PBL and the Bico bottom hole motor, 2 7/8 in Spirostar. After the milling of 3 to 6 plugs, we've been washing out the debris with the flow rate of 2.5 times higher than the maximum flow rate for the bottom hole motor. And to summarize my presentation, we recommend using the bottom hole motors to reduce the milling time and the time for the trip. Also to reduce the number of trips and to minimize the fatigue for the replacement of the bottom hull motor. Also, when we're using aggressive flushing fluids and when you're pumping down acids, in that case, you should be using that with the PBL, and also to wash out the wellbore, also in combination with PBL. Thank you. This is everything that I had. And if you have any questions, I will gladly take them.
Пожалуйста, коллеги, вопросы имеются?
Yeah, colleagues, any questions, please?
Вопросов нет. Денис, спасибо вам
No
за доклад.
Thank you.
Удачи.
Yes, have a good day and all
Мы
the best.
переходим к следующему докладу
We're now
этой части.
opening the floor for the next presentation.
По нашей программе должен читать
Which is
User
going to
Chari.
be
Колдюбинговое бурение, как
by
интеграция технологий
User Chari
колдюбингового
is going
бурения
to
и
speak about coiled
скважинных
tubing,
работ станет
enabled
новой
drilling
нормой
as
для
integration of the coiled tubing
отрасли.
drilling, and how it's going to become the new normal for the oil and gas industry.
Так, связь у нас есть.
Do we have connection with the
Пожалуйста,
speaker?
Hi, everybody. Can you hear me, please? Is it clear, eh? Okay, sounds good. Thank you very much for this opportunity. This is my first time for me to be in Moscow, even though it's online. I'm calling from Istanbul from my hotel room, actually. Thanks again for this opportunity. Today, I'll be presenting how the well intervention and drilling technology integration will be the next normal for the oil and gas industry. And I will start with the oil and gas 2020 outlook as an insight for the situation of our industry. And then after that, I'll move to how we're going to make our oil and gas industry great again after this kind of a hard time that it's going through. And one of the solutions that I will be presenting is the underbalance drilling with coiled tubing. And then I will link that to the integration between well intervention, drilling technologies, and the reservoir characterization, and how we're going to make our industry flexible, resilient during recessions, and flexible in terms of fast recovery. And then finally, I will close with the CTD business challenges, since it's still considered as a niche application. So for the oil and gas 2020 outlook, I will start actually by the International Energy Agency outlook in 2010, and those outlooks they were projecting a fair oil and gas demand by 2020, and we can see that after 9 years of that outlook back in 2019, just before the pandemic. But then once the pandemic occurred, and then with the glut of oil that we faced back in May 2020, that oil and gas demand dropped drastically. And then the outlook 2020 from the International Energy Agency has completely shifted, and they shift basically strategies by pushing basically more renewables than oil and gas. We all know that oil and gas industry will be always needed, not only for energy or electricity, but also for other side industries like car, like medical and stuff like that, right? So the problem is, from the other side of the Atlantic, we can see completely different outlook from the U.S. Energy Information Administration. Right, the guys in the U.S., they're predicting if the pandemic will end very soon, then the recovery will be faster, especially for the oil and gas, specifically for the shale. So this gap between both of the outlooks, it makes the prediction not really linked into technical or financial challenges I think it's more into a political challenges that the International Energy Agency is working on. And this is basically what the next slide shows, because one of the things that the oil and gas industry those days is facing kind of a rally of distortion, harming basically the reputation of our oil and gas industry. In the left-hand side, we can see the global map of the CO2 emissions. One of the things that for example, environment activists or even the International Energy Agency is focusing on is basically the CO2 emissions. We can see Canada, US, North Africa, Middle East, some part of the Eastern Europe, Russia, Southeast Asia, China. All of these countries, oil producers, they are basically considered as the highest countries' emission. But paradoxically, the right side map, it shows the globe by night. Basically, the countries light during the night, and we can see that the most latent countries are the one in the the Western Europe. I mean, you can see France, Italy, UK, all these countries that they are calling for basically cutting with the oil and gas industry by 2050 with zero emissions. These are the most countries that they are mostly lightened. So, with all of these challenges that the oil and gas facing, how can we make our industry great again? It's basically kind of a strategic change management that the industry, the International Energy Agency is going through, trying to unfreeze the current situation, perform the changes, and then after that, refreezing again and implementing the changes. And I think this is what we need to do as professionals and practitioners of the oil and gas industry. We need definitely to define our challenges, understand the need to change, because our industry right now is facing these kind of allegations and distortions. We have to clear the public opinion about these allegations, and we have to define our current resources, equipment, manpower, technology, and then we set our new strategy and implementing that strategy and enforce it. So for that, our new founded company, the Coiled Drilling Consultancy, we went back 40 years back to the 80s where the oil and gas was booming. And then we studied those 40 years in terms of challenges using the PESTEL model, the political, economical, social, technological, environment, and legal. And then we come up with the last 15 years or the last decades, basically, and we spot the main challenges and we summarize them in the next slide. We reword them, rephrase them with our oil and gas industry wording. So we found that the main challenges were basically safety, environment, and profitability. So for safety, we can see that a lot of allegations basically or reputation that we're facing the most hand and fingers injury, the blowouts, the H2S releases, even though the oil and gas industry is very well known as the classified second after the space energy in terms of safety and process orientation, right? From the other side, the environmental challenges is basically coming from the emissions, the spills that we saw in several incidents offshore and during the transportation of oil and gas as well. They also considered that frac at one stage presents some basically danger or hurting the water reserves in some of the areas. And like, for example, in 5 or 6 years ago in Germany or also in Arkansas, the environmental activists they're using the micro earthquake as a pressure point on the oil and gas industry, especially in the US, to reduce the activities or to stop it, basically, in some of the areas. Now, coming to the profitability, well, economically, if the technology, we know that the technology basically is used to improve delivery for the oil and gas. And if there is no technology, if there is no investment, there is no technology. And the investment comes from political stability on the worldwide. And from that perspective, if we don't have that stability, we can see those glut of production, the pricing drop that we faced back in April and May 2020. That will affect basically the service companies as well as the operators. And for that, we have to find a kind of a new way how to operate and how to overcome those challenges. So if we go back to the safety, then we can find out that in the well intervention, coiled tubing, for example, present a good technology or a good technique for drilling because of the continuous piping, the absence of pipe handling. There is basically no blowouts in coiled tubing, especially under balance drilling, because on under balance drilling, the well is alive all the time. So it's the coiled tubing package and the under balance package are basically equipped to hold pressures on the wellhead. From the other side, the drilling with coiled tubing is basically targeted to the reserves. There is no contamination to such, whether it's said water reserves or whatever. So it's basically targeted, comparing to some of the challenges that some other techniques are facing. So strategically, CTOBD is a reliable solution from a safety perspective, from an environmental perspective, and from profitability. So if I'll take a quick break and just remind everybody about what CTD is, because I'm quite sure that everyone is now familiar with coiled tubing drilling. I remember seeing in the summary of 2019 of the Coiled Tubing Times ICoTA-Russia that there was a presentation of coiled tubing drilling. So basically, it's a through tubing application using slim hole, whether it's a wide BHE or a slim pulse or whatever, to drill to the target reservoir. So one of the main advantage of this technology or this technique basically is the reduced HSE exposure. We don't have any people handling pipes. The completion stays in place. So that's a profitability basically for most of the operators, and try to intercepting several reservoirs through one motherboard, plus other advantages, high build-up rate, and then basically an independent telemetry, regardless of the hydrocarbon produced, whether it's gas or oil. So the telemetry remains working, remains viable. Now, going back to our business case, why is the oil and gas is facing those kind of cycling, basically? Now, when we look back to the previous 15 years on the data for the US and worldwide, we found that the cycles of the recessions were basically always, and then I'm really emphasizing on the word always, it was always less than the depreciation time of the equipment. So if you can see on the left-hand side of the graph, as soon as we have a recession phase, especially for frac activity, this is the most activity that is getting hit, especially during those pandemic or those recession time. As soon as we have a recession, we can see that the frac spread count is dropping until a stage that the companies will have to do some liquidation of their equipment, right? and then as soon as there is a recovery, then after that, we start counting the recovery time, and it had never been between 7 or 8 years. This is basically the typical depreciation time of a frac equipment or a well services equipment. And then this is really sad, and I can tell that, in my humble opinion, it's sometimes I can feel that it's really intentionally, but anyhow, that's not really the ground to discuss about that. Having a depreciation time of 7 years comparing to a recovery or a good oil and gas timing of like 4 or 5 years only, we can see that from the 2017 recovery and then another recession back in 2020, that's only 3 years we're talking about, and then we can see all of these frac fleet laying down, whether in the Middle East or a U.S. land or in other countries. That goes the same for the rigs as well, except for the fact that the useful lifetime of a rig is longer than a frac fleet or a coiled tubing fleet. It's basically counted by two majors maintenance, which is, I would say, 10 years. And this is why on the right side of the chart, you can see that the cycles for the rigs is basically 8 to 7 years. It's always never been on the depreciation time of that equipment. So how about the coiled tubing and well intervention in general? That's one of the points that create basically the resilience of this industry. Now, during recessions, well intervention integrated with drilling and also reservoir characterization with well testing equipment and all of these equipment, they can give or they can offer a more resilient business model during recession, and then more flexible during recovery, especially the fast recovery. And I'll explain that in a while. So during recessions, I saw some of my clients previously, they were calling for coiled tubing drilling during recessions, especially to go through their brown fields, the proven reserves, and then trying to re-entry those reserves. So during those recessions, still operators can produce and can drill using coiled tubing drilling. The equipment versatility, coiled tubing drilling equipment, you can use them either for the drilling per se, but also if there is a recession, it can go back to the well intervention. I mean, it can go back from where it came from, right? Same for the testing equipment or even for the drilling equipment. Now, for the manpower also, the multi-skilled manpower that the coiled tubing drilling has, give the opportunity to the service company and operators to avoid layoffs or at least reduce layoffs during recessions. And that gives a good reputation in terms of CSR, corporate social responsibilities for those companies towards the government that they are working for or towards the community that they are working for, right? Now comes for the recovery, which I will go into the deep details for that in the next few slides before I wrap up. But mainly, during recovery, we recall the 2017, the heat for coal on the rigs, and there was a lot of field that they were waiting for their turn to be drilled because we were missing actually a lot of rigs, and the rig count was really not fulfilling the demand of drilling. And during that point, one of the operators in the Middle East, he had the idea of overcoming this situation by using coiled tubing drilling. And how is that? Basically by going through a revolutionary approach, hybrid drilling. So instead of drilling conventionally a well and spending 90 days or whatever during 2 or 3 sidetracks, instead they were drilling to the top of the reservoir, complete the well, and then move. So they call it a preset well. And then after that goes and spud with coiled tubing drilling and drill whatever, 3 laterals, 4 or 5 laterals, depends on the objective of the reservoir target. and then after that, test the well and produce. The beauty of this technique is basically it shortened the time of drilling, and we can see that later on the utilization of the rigs, right? Instead of spending 90 days on a well before we deliver it to the production, we can only spend 50 days plus the 25 days of CTD, 75 days in total before we hand it over to production. And then we can use better our conventional rig fleet. It also gives the possibility of the first hydrocarbon after 50 days. Because once we drill with coiled tubing drilling, the first time you hit the pocket of the reservoir, then after that you can drill while producing. Right, that's the beauty of that technique. The rig utilization definitely will increase, and then more footage and more exposure. Now, just a quick insight on this particular operator in the Middle East, how they were managing their drilling fleet, basically. So on the first line, you can see that if we go for conventional drilling with one rig, then definitely that rig will only drill 4 wells if everything goes smooth, basically, right? But if we use the hybrid technology or the hybrid approach, then that particular rig will be able to drill almost double of whatever used to deliver, right? And at the end of the day, or at the end of the year, we will be able to deliver to our production client almost the double of whatever will be reused, basically. Now, if it's that really wonderful technique, right? So why is it still kind of a niche application? I mean, it's not really spread wide in the world. I can see that it's only Saudi right now still drilling with coiled tubing drilling. I think Alaska. Some projects were going on and off in Russia. Lately, I think in Abu Dhabi, I think they are calling for a project. So it's a niche application, right? And the reason for that is basically the marketing, and this is basically the core of our business in Coiled Drilling Consultancy, our new founded company. So we will try to help both operators and service companies to understand and to implement this kind of technique within their activities. Now, why I'm saying that? Because the problem with CTD is always perceived as an expensive technique, right? That's what most of the operators, the first thing that they will ask you is basically, how much is the day rate? I mean, we cannot ask about a day rate of a technique that gives you a well after 25 days comparing to a conventional drilling rig that gives you a well after 90. So 90 versus 25 days, we're comparing apple to oranges. I mean, we cannot really compare apple to apple. The next slide will show you exactly on perspective the pricing and the comparison basically between CTUBD and the conventional. Then that created a lack of knowledge among the operators. Some of the operators, I know that they do have engineers. I've been working with a lot of smart engineers with them on my previous coiled tubing drilling projects. However, with the progression plan of these people, there is no continuity. There is no continuous plan. And people who are filling in for their position, they don't have, unfortunately, that CTD background. And basically a project management aspect as well, because coiled tubing under balance drilling, it's all about project management. It's the coordination. It's the art of coordinating all the aspects of drilling, testing, well control, and all this kind of stuff. Now, the same challenges the service company are facing, but in a bigger scale. Because if you are a service company and you've been called by an operator to perform a coiled tubing drilling and you don't have the the resources, then that's a big issue. And that's why service company has to start building capacity for manpower, especially for the field, because we don't have enough. For the project management team as well, we don't have enough. And this is where we can help both operators and service companies. And basically, the start of, or the approach of pilot project, I saw some of the projects, they were dealing with only one candidate. Unfortunately, that's not the right approach. Quantum drilling and balance, especially if it's first time implemented with an operator or with a service company, it has to be through a pilot project, 4 or 5 wells, to build a lesson learned, because every field and every country has its own challenges, has its own terms and conditions for this kind of techniques. Now, as I promised, and I'll try to readjust this perception, and I would like to thank my previous clients for allowing me to share with you this kind of graph, provided that the numbers are hitting. So I'm trying to make it as a scale. I promise that these are real numbers, but then for the confidentiality purposes, for my clients, I'm just presenting those graphs without numbers, but then just to show you the scale. Now, for the rate gain of an underbalanced drilling compared to conventional drilling, we're talking about almost the double. And this is per well, and this is the rate. I'm not talking even about the continuity of this production. There is an SP paper I can share with you. If you'd like, you can contact me through the host of this session. You guys all my contact, and I can share with you some of the SP papers that have been written by either my team or some of the engineers from our clients, Aramco, Petronas, all of these wonderful clients that we've been working with. The reservoir contact also, we're talking about almost double, because with underbalanced drilling, we can drill up to 4 or 5 multilaterals from the same motherboard, depends on the candidates. The drilling cost per foot, it's really wonderful to see that graph, and I really thank that particular client who allowed me to show that. I mean, the cost per foot, the drilling cost per foot for conventional is really high, especially after the drilling, after the completion, basically. Now, the drilling duration, definitely we cannot compare 90 days compared to 25 or 26 days. And then finally, the unit developed 1,000 scuffs. The cost of those units, dollar per 1,000 scuffs, it's almost the third or the 25% of a normal conventional drilling, because most of the cost goes after that, after drilling and recovering with stimulations and all of these kind of interventions after that. With that, I concluded my presentation. Really thank you for your attention. That was my storytelling, basically, and my call for how to make our oil and gas industry great again. And this is a story that I would like every one of you spread it out through the corridors of your client, of the service companies, that you can keep our oil and gas industry great by changing the way we're working, not only with the technology, but also with the strategic changes. Thank you very much. Any questions?
Спасибо за доклад. Силы на вопросы есть? No questions. Thank you very much.
Well, thank you for the presentation. There are no questions at this point. And thank you for having...
У нас осталось 3 небольших доклада на сегодня, все русскоязычные, поэтому будет несколько проще. Значит, первый, что из остатков, это будет замена и технические проблемы, которые из завтрашнего производства и модернизация оборудования для гидроразрыва пластов. Артемюк Ростислав Валерьевич, директор по развитию ООО «Нефтемаш». На связи у нас? Все слышно? Пожалуйста, тогда.
Good evening, dear colleagues. So thank you once again. Good evening, ladies and gentlemen. I would like to thank the organizers and sponsors of this conference for inviting us to participate. This is a first experience of the kind. And I will tell you about what we've been doing so far and the success of our recent operations. We've been managing 3 projects to modernize the production, and while also offering service projects for cementing, which might probably require a separate conference to explain it all. We're not going to explain our prospects and development plans. Everything that we present here is something that has been recently implemented on the equipment in Western and Eastern Siberia. The classification of the projects is quite easy because we're now developing new aggregates and new pieces of equipment from scratch, while modernization means that we are updating.
Сборочные цеха находятся в городе Сургут, также размещены производственные площадки в городе.
We are based in Surgut and we have facilities in Zlatoust.
И опытная команда конструкторов, инженеров.
We have a rather experienced team of designers, engineers, and narrow field specialists. We design and have all the specifications for all fleets, including pumping unit, hydration units, chemical blenders, heating stations, and water feed stations. We've also developed and implemented projects involving coil tubing equipment.
Богатый опыт глубокого реинжиниринга оборудования по ГРП и ГНКТ у нас имеется.
We have some experience of running different projects using coil tubing-based multi-stage fracturing, also producing key equipment for fracturing, and using the control systems based on Siemens components. A few words about the activities in machine building. We are developing the design documents for all the equipment that is produced, which is based on technical specifications from the customer, while creating 3D models and set up assembly solutions, while designing technological cards for the and mapping of the industrial processes, while piloting, designing, optimizing procurement processes and logistical elements, designing and assembly of the multi-stage fracturing modules for further supply of the equipment, adapting the software for tailoring software for specific requirements, adapting it to working with different vendors of hydro fracturing equipment, and while producing warranty and post-warranty maintenance and service.
Здесь на слайде представлены
The list of projects that we've recently implemented.
То есть у нас произведено насосных агрегатов.
We have produced a number of pumping units to 250 horsepower up to 2500 horsepower, 13 pumping units with the cumulative hydraulic power of 31,500 horsepower.
Кроме этого, значит, установка химических добавок.
This is the chemical agents feeding hydro-driven unit and hydro mixing and blender system with electric drive, and we are offering the modular assembly deliverable by helicopters. This is the technical heating unit with 7.1 million BTU per hour boiler capacity, and we're producing the third fracturing control system. By cooperating with the leading producers of equipment in Russia, we are using locally produced components or with the international equivalents. We're working with different producers with Belarus and Kazakhstan. And we have designed and localized the sandwich type radiator. Similar things are already being produced locally, including high pressure pumps.
Реализованы также радиаторы типа сэндвич, полуприцепы.
I'm also producing 3-axle semi-trailers for conventional roadways.
Да, параллельно вот еще
The self-propelled 8x8 chassis and 10x8 chassis from our Riyadh partner company.
Самоходном шасси, насосных агрегат, то есть на 8х8 и 10х8. Да, мощностью от 2250 до 500 лошадиных сил. Разработано универсальное программное обеспечение.
A few words about the localization of production and import substitution in the implemented projects. We have produced universal software for every unit of the hydrofracturing fleet, which works with different vendors of hardware, different auxiliary pumps, drive shafts, heat exchangers, industrial brake systems, fittings, hydraulic sleeves, fluid heaters, conveyor belts, mixers, blenders, control systems, exhaust systems, and etc. All measuring instruments and fittings, all that is produced by local companies. I understand that you might be asking questions about the engines and transmissions. The engines and transmissions are only foreign ones. We don't use the Russian-produced ones. We've done a lot of work to do in-depth re-engineering and upgrades of the obsolete technologies that were previously, but the earlier fleets were running out. So we are now offering retrofitting and updating projects for changing the chassis, updating units for new and swapping for new equipment, while also rewiring and upscaling the capacity, performance, and power output of individual units of hydrofracturing rigs. We have extensive practical background of re-engineering, capital work over and restoration of different blenders, gel hydration units, technological fluid preparation units, chemical additives, pumps, fracturing pumps, and cementing equipment.
сборочное производство в регионе работ, профессионально опытную команду,
Offer
проработку
the assembly in the areas of operations done by professional and expert team, turnkey projects, timely maintenance and service. Thank you for your attention, and that's all from me.
Спасибо, Ростислав Валерьевич. Вопросы у нас есть? Да, я вижу. Подайте микрофон, пожалуйста.
Слышно? Добрый день, Ортисервис Дмитрий. Я как понимаю, после капитального ремонта либо модернизации техники какие-то должны быть документы, да, подтверждающие, либо согласно чему изготавливается модернизация. Я имею в виду, это технический регламент Таможенного союза 10, машинное оборудование 18, колесный транспорт. Какие у вас идут после модернизации документов? Есть ли сертификат собственного производства? В частности. Спасибо.
Well, we're still developing some of them. Of course, it depends on the requirements. Some of the customers don't need that. Sometimes they just need in-depth modernization.
Ну, я имею в виду даже пункты ФНП, это пункт 52 и 54, который говорит о том, что
Clause 54 and 58 of the technical regulation that stipulates that after technical modernization, you need to conduct the expert assessment of the health and safety. So whenever the customer requires that, we of course are able to provide that.
Спасибо. Еще?
Any other questions?
Больше вопросов нет. Спасибо за доклад.
Thank you.
Так, переходим к предпоследнему докладу сегодняшнего дня и секции. Значит, Степана Владимировича Люберже. Прольет нам свет на работу с ГНКТ в скважинах с многостадийным заканчиванием. Так, у нас нет тут сообщений.
Just unfortunately, my camera doesn't seem to work, so I won't be able to be feeding the video.
Напрягаем слух, будем слушать, пожалуйста.
Так лучше?
I hope that works.
Как меня слышно?
Do you hear me?
Слышно хорошо.
Yeah, we see you.
Спасибо.
Good, thank you.
Меня зовут Владимир Степанов, я инженер компании Шлюмберже, и сегодня я хотел бы предоставить вашему вниманию очень интересную методологию, которая была применена на тенгизском месторождении при проведении кислотных обработок с ГНКТ. Данная презентация основана на докладе SPI под номером, который это краткое содержание того, что будет в презентации. И так начнем. Как я уже сказал, это методология, о которой мы поговорим, была применена на Тенгизе. Тенгиз – это гигантское нефтегазовое месторождение, которое расположено в Казахстане, и, если быть точнее, на северо-восточном побережье Каспийского моря. Вместе с соседним королевским месторождением Тенгиз разрабатывается компанией Тенгиз которая является совместным предприятием при участии Chevron, ExxonMobil, и Lukoil. Площадь месторождения состоит около 400 квадратных километров. Высота нефтяной залежи доходит до 1600 метров. Запасы нефти в пределах 3,1 миллиарда тонн. И ежегодная добыча составляет от 20 до 30 миллионов тонн в год. Это карбонатное месторождение. Содержание сероводородной нефти составляет около 13-14%. Также присутствует неравномерное истощение пластов за счет неравномерной добычи с разных горизонтов. Также наблюдается большой контраст пористости и проницаемости между разными пластами.
different
На Тенгизском месторождении есть разные типы скважин, которые служат разным целям. Среди них есть добывающие скважины, газонагнетательные скважины, вододобывающие и водонагнетательные.
Gas injection wells,
Вы видите,
water producing wells, water injection wells, and producing wells.
Месторождение разделено по зонам.
You see that the oil field is divided into 3 areas. In the central part, we see the platform, production according to the matrix.
Так, секундочку. Да, то есть в центральной части месторождения мы видим платформенную часть, где добыча идет по матрице. Вокруг и окружая платформенную часть мы видим обод или верхний склон, который еще раз окружает платформу. Он имеет высокую трещиноватость и также имеет самое низкое давление, но самые высокие дебиты. И окружая, получается, ободную часть или верхний склон, мы имеем сам склон, который является внешним контуром. И он, получается, характеризуется низкой трещиноватостью, и добыча у нас идет как по матрице, так и по трещинам. Вплоть до 2018 года на Тенгизе использовалось 2 основных типа заканчивания скважин. Один цементированной колонной с последующей перфорацией.
Column with subsequent perforation. It was done with
С другой стороны, на скважинах с большими
recovery,
низким давлением применяли метод заканчивания с открытым
we adopted the completion with open bore. Although these are standard methods that are quite easier to use, they also have certain limitations, namely inability of selective production, also limited success of acid treatment, because we're speaking here about 600-meter intervals, also limited capacity in case of gas and water washout. Also, unpredictable behavior of the wells also meant that we had to consider both types of completion. And to address all those issues and unify the approach to completion, our company decided to introduce multi-stage completion, which is basically a hybrid between the above-mentioned completion types. This type of completion means using uncemented column with swallowable packers, which allows shutting off the producing intervals. Every interval is available through ports that can be triggered in different positions. The positions of the ports can be adjusted by the CT and also when doing the wireline operation. Since this was a huge investment and an important step for the entire oil field, we had to have instruments and tools to demonstrate the efficiency of these interventions. Basically, we needed to demonstrate whether packers will operate in Tengiz conditions. It was also important to see the distribution of fluid in every zone, which is another important area. And of course, it was critical to have an approach to manipulation of the ports and prepare the wells to production. These were the key tasks that we had, and together we're able to find the suitable solution to address all of these challenges. So the solution was to use the active services. Active is the commercial brand of the technology. Basically, it means optical fiber running on CT stream. It's a combination of all head and bottom hole equipment connected by the fiber optic cable that is found inside the coil tubing. Here we have the layout. So this is the circle, which basically is the spool. Inside the spool, we have the communication module that interprets the data and sends it to the cabin over Wi-Fi. The module is connected to the fiber optics, which is fed into the CT, and the CT runs along the entire length of the tubing and goes all the way down to the bottom hole string, where it connects with the different end bits to feed us the data. At the other end of it, downhole, we have the following string. Of course, it all starts with the connector, then the fiber optic separation module in case of emergency. Then we have the telemetry module, which is pressure and temperature module. We have the internal and external pressure and temperatures. Then the sleeve locator, logging module, and pull and tension module, and the key motor and end. So why do we need all that equipment, and how it would be helpful?
Как мы видим на экране, это пример закрытия одного из портов.
This is one of the cases when the port is getting closed. This is the chart that shows the locator of the sleeves. Which tells us that we are where we want it to be, and we see the port, and we want to work with it specifically. We have the tracks here for bottom hole pressure. By using these two values, we saw a differential value that we have for our tool, and since the tool is hydraulically operated, we knew definitely when it's activated, because we knew the bottom hole pressure and what the tool is going to give us when it's activated. Also, another important thing was that the bottom track is the surface value for the weight of the CT, and the bottom hole pull strength, which is part of the bottom hole assembly that's called active. So judging from this screen, we know the variability of the CT weight within 1 to 2,000 pounds. We don't have a very clear view of whether we are actually loading meaningfully the port that we need. But judging from the bottom hole load sensor, we see that the pressure applies. We know that the key is activated. We are at the port depth, and that we are actually delivering the load that we need to operate the port. And we see that from the bottom hole data. But this was also quite critical, because the pusher key that we were using to operate the ports was also limited in terms of the bearing load and pull strength that were quite low, which means it was extremely important to be within the range of these values, so as not to disrupt the key and as not to undermine the entire operation. Another important element for using active technology is to use the distributed thermal temperature sensing. In other words, this is the temperature profile of the entire well, with the optical fiber serving the instrument itself, and it actually helps us identify the fluid distribution across the productive interval. The temperature profile is registered across the entire string by sending light readings through the optical fiber. And the data reaches the surface, and that's the reflected light is analyzed to analyze the temperature. I'm going to speak in greater detail about the temperature measurements and three key elements that have been used to analyze the data during the distributed thermal sensing. One of the basic elements was the baseline curve that we do, the reading that we get before the temperature balance gets disrupted. The baseline is done while the well has certain downtime. Usually that's done during the first trip to basically read the inert well. The baseline is done as a benchmark against all other readings of thermal sensors, and we'll see that we see them in all our charts and all our tracks, and we usually have it in green. So this chart that you see here, so on the left we see the well schematics. That dotted line shows us the ports and the isolated intervals by swallowable backers, and we have them in different colors. Every interval за которым закреплен определенный цвет, снизу и сверху у него набухающий пакер. And we have the swallowable backers above and beyond every isolated interval. The second element is the cooling curve that we see on our screen. We also see the source curve. But this is done when we're feeding the fluid down the well, which is of lower temperature than the reservoir temperature. We have, it's in a black line, we have the intermediate temperature profiles represented in gray, and the blue line is the cooling line, and it shows the last point before we stop the pump down, before we shut down the pumps. So it's basically the coolest curve. So what does it give us? We use this cooling curve to see whether we have connection to and with the lower intervals by using a simple logic. If we pump down the cold fluid, that goes down and brings the temperature down along the well, then we will see at which depth the fluid, which depth the fluid actually reaches. The optical fiber itself is inside, and we see that, and we do that for the annulus. And this is how we record the profile. So if we don't see the cooling, in that case, we're doing that through the third port, and it's actually feeding here through the third port, and we don't have any connection with the lower intervals because we don't have any cooling and any change in the temperature profile, so we're confident that we're not feeding it lower than the interval that we're pumping it down, and that's it. The last element that I wanted to mention was the heating curve. So this is the period after immediately the pumping is stopped. So because this is the track that we see which gives us the and also have in reverse, the black line is the coolest part immediately after we stopped. The gray, the light green areas are intermediate. The red line is the last moment of the reading. And of course, it's dictated by the geological features of the reservoirs. So why do we need the heating profile? Whenever we're checking the cooling profile, we cannot really say whether we have a connection with the upper intervals, because we're pumping the fluid through the annulus, which means that the entire profile gets disrupted, and we're seeing the temperature of fluid above the isolation line. So we can say whether we are reaching the lower ones. When we are looking at the heating profile, we can already say, just by judging how temperature operates, that we have, whether we have or not, the connection with the upper intervals. Because we're using the simple logic of thinking that the reservoir that receives cooler fluid from above will be actually or warming up more slowly. And as a result, in this interval, we see a rather slow heating interval, which means that this is the interval that received most of the fluid. So basically above the third zone, so zones 4 and 5, right now we don't have connection with them because there's no slower connection. And I will tell you how this data can be interpreted when we had to apply this at the Tengiz oil field. So of course we start with opening the port, and then we do the receptiveness check and dividing that with an inert fluid, since we're speaking about carbonate reservoirs. So the acid treatment fluids are hydrochloric acid and different hydrochloric acid alternatives. But to do the baseline reading, both heating and cooling, we're using inert fluids to not accidentally provoke the connection before we get into data. So after we do the probability reading, we also do the heating profiles. And after that, we get the perception of whether we have the connection between the intervals. And if it's all okay, and we do the acid treatment if we don't have any later readings. So we also, using different temperature profile readings,
закачивая кислоту, мы не спровоцировали сообщение между
if we see that we see no connection, no communication between the packers, if we're speaking about the coordinate,
есть риск того, что
the carbon deformation, and the acid might also affect the surface of the formation, which touches upon the soluble packer. And we read that temperature reading that we call heating B to have a clear understanding. After that, we close the port that we've been treating, and then we start treating the next. I would like to show you what we saw when using this methodology. In this slide, you see the case of good isolation. So here, we're injecting through the third port into the third interval. Once again, this is done through the annulus.
То есть по профилю охлаждения мы видим, что у нас нету охлаждения ниже.
We see that we don't have any cool down lower than the third sleeve.
И также на профиле отогрева.
And also when we're looking at the warm back,
мы видим, что у нас нету сообщения.
We see that we have no connection and we have no retarded warm back at interval 4, and everything is, all the fluid is localized between intervals 2 and forming between the packers of the interval 3, meaning that the sleeve zone is the one that we're actually targeting for injection.
Теперь хотел бы вам показать один из примеров. Это
I wanted to show you the case of
который мы тоже заметили, это
that we also witnessed was the connection between different completion zones. So I'm pumping down zone 4 through port number 4. So the fluid is coming here. But as we see, the cooldown profiles, the cooldown is going down to zone 2, which means that we have connection with the lower zones. And the question is, what is the connection mechanism? That, of course, we have recorded the cooldown and warm back profile. Analyzing all the data, we ultimately see that this was done through the soluble packers. How so? I guess this couldn't have been just because whenever we do the manipulation, we do that after the casing, which we can also do before the next temperature reading. In our case, we didn't witness any connection, any bypass between the ports. And we knew for sure that we've been working with zone number 4, and there was no fluid. We also saw some abnormalities and we saw the similar performance with soluble packers across different intervals. But when we looked at the warm back profile, we saw this abnormality almost completely disappear. And that basically told us that the connection was through the packers, and these temperature localized abnormalities that we witnessed were caused by the Joule-Thomson effect, where we've seen the changes in temperature when forcing fluids through bottlenecks. Another case was the connectivity through the formation. In that case, we're pumping down the interval number 3.
Вот, этот пример я ранее показывал. Вот, о том, я показывал как пример хорошей изоляции, да? Но это был пример.
Used to show it as the case of good isolation.
Вот, но когда мы прокачали соляную кислоту, то мы увидели после того, как мы записали профиль отогрева,
but whenever we did the warm-back profile, we saw that we have a retarded cool down in the lower part of the fourth interval, which basically told us that we have connection with the fourth interval. So once again, by looking at the cool down profile, we don't see that it's cooling down below the injection zone, so we have no connection with the lower zone. But since we are seeing the slower back of the lower zone, we are judging that we have connection with the lower zone. So once again, going back to the earlier case, since we didn't have any such abnormalities, we believe that this was the connection through the reservoir, or potentially through the system of cracks that basically bypassed the system of soluble packers. Another interesting case that we witnessed that showed the advantage of using the fiber optic technology was the next case. So in that case, we're pumping down the second port, and we saw the fluid coming down the second area through the second port. And there's no come down, there's no cool down, but we have poor permeability. So we try to pump down the fluid. And basically, we see growing pressure because we're pumping down the neutral pressure. And at some point, the curve becomes flat. So in terms of hydrodynamics, that tells us that basically we're looking at that we're already doing fracturing.
В какой-то момент, и мы, в принципе, если здесь посмотреть, то есть мы пытались закачивать жидкость с расходом около 2 баррелей в минуту. Да, я уже близко к завершению.
Almost finishing here, and this is when we see the drop in pressure here. We also see the cool down of the area that was below the injection zone, which basically tells us that we've been doing the hydrofrac job successfully and that we've induced communication with the lower area. So what have we done as the takeaways? This is the number of operations that we've done. We've done it on 26 wells, 93 intervals with 111 ports opened and closed successfully. We've also developed the system and databases with different communication mechanisms and with different methods to minimize or to prevent the connection between different reservoirs. And so here's the data that we've used. We've been using thermometry and specific measurements that were required to calibrate the temperature and do the readings from the bottom hole instruments. So we concluded that using using tailored equipment has more benefits and should be prioritized when conducting well interventions at similar oil fields. Thank you.
Вопрос имеется? Вижу. Принесите микрофон.
Также Волга Аликоин. А подскажите, с какого материала было окончание, потому что сероводородная среда
what was the completion, because you have
и там
H2S environment and
инструмент очень
часто it usually causes problems for the instruments. It's a good question. So when we do any coil tubing operations, we usually do the neutral fluid substitution. In our case, we're using stabilized Tengiz crude, which is its local degassed oil. So we haven't seen any H2S for the normal instruments, because we usually do everything in overbalance setting. One important moment is that whenever we pump down the acid, especially when the flow rate is low, when we're pumping through the annulus, there's potential segregation of fluids, and basically the hydrochloric acid going down, with that, which at low flow rate might actually build up below where the bottom hole assembly is. And that, of course, leads to erosion. But the bottom hole assembly activa is produced from resistant materials that actually withstands that kind of environment.
Я имел в виду именно порты сдвижные, потому что, получается, вы сказали, у вас ключ имеет ограничения, просто я к чему вопрос задал. То, что компоновка зачастую, находясь в забойной сероводороде, она закисает. У вас были ограничения по ключу. И как вы, соответственно, сталкиваясь с такими проблемами на сероводородных скважинах, что клапана закисают, как вы боролись с этим, вот, с закисанием клапанов?
Ну, смотрите, у нас пока истории в этом не было.
We didn't have any cases like that, actually, because all the valves that we've done are, and that we've that we've worked with, we're with brand new equipment, so we're just recently completed. But
инструменты, которые, допустим,
different tools,
которые могут как джетить, да, то есть
that can, such as jet blasters that have special nozzles that you can use to disrupt the organic settings. And there are also chemical agents that can help remove organic calcifications and
карбонатных отложений, которые, в принципе, тоже убираются вот такими инструментами, которые выдают жидкость под давлением, да, и использование кислоты, да, в этих условиях. То есть, в принципе, конечно, это будет зависеть от конкретной проблемы с портом, да.
And on the
в качестве датчика нагрузки концедатчик использовали?
Нет, в качестве датчика нагрузки это вот использовался модуль
As for the load sensor, we used
как один из модулей системы Activa.
The Activa module.
Через все эти инструменты, которые я показывал, через них можно вести закачку, то есть через них можно бросать шарики, вот, то есть они в принципе является частью системы
So this is something that we've been doing with the active system and the logging and the sleeve locator and everything else was all that bottom-hole equipment is capable of feeding the fluid through it. Because we have the pusher key, which is hydraulically operated at the end of it.
Спасибо, Владимир.
Thank you, Vladimir.
Переходим к заключительному докладу сегодняшнего
And we
этой
are
сессии.
opening the floor for the final presentation for today. I'm going to speak about special equipment from Kazakhstan.
Хотя бы единственного докладчика сегодня вживую увидим в этой сессии.
This is the only speaker whom we have in the audience, Evgeny Bondarenko, Deputy Director of Riyadh.
Постараюсь с учетом того, что время, максимально коротко построить свой доклад.
I'll try to briefly report on our achievements.
Задачи импортозамещения. В каком смысле?
Stressing that we are doing import substitution here. So we're all they're all employing either
программой в течение 28 лет имеем накопленный ресурс,
semi-trailers or self-propelled chassis. We have been working with that topic for 6 years.
Компетенции, суть которых работать
we have certain competences, which is to work informed by the customer's requirements. In addition to that, we need to be able to provide good service. So our competencies are that we've been producing and gearing our trucks to the specification of the customers, and we're able to produce those, which is illustrated by the completed projects. So today, all the auxiliary equipment can be mounted on this special self-propelled chassis by KAMAZ Riyadh. Of course, we basically are watching from the pocket of the consumer, meaning that it needs to be more cost-efficient to run everything on our local chassis. So basically, we're trying to substitute the import. How do we do that? We do that to optimize, for instance, the engine by using the locally Cummins-produced diesel that has a flat torque line at about 1500 RPM and can be actually pull everything out through the swamp. And it also offers good fuel efficiency. So here's the presence that we have in Russia. This year, we're present in 800 units, planning to expand that to 900 units by 2021. And the geography is quite diverse. So we have presence both from the east to the west and from south to the north. This is the illustration of our customers. These are the VAPs, Katco, Neft, of course, Rosneft, hundreds of vehicles that we ship. Packer service at the end of this year is our biggest partner. Also, in Mongolia, we are working with the state mining company. Of course, this is the KAMAZ that we've retrofitted with the semi-trailer. This is from Catco Oil, and also how we're present on Taimyr. This is basically the shoreline operation. different bullet carriers. This is KAMAZ Vankor or KAMAZ Batyr groups of products. AGS, our long-term partner. Petrovel Technologies, also present in Kazakhstan, and with Batyr, also AGS, with 2.5 megawatt output. I know that nobody else was able to produce the running fleet with the similar output. Also, we have the gas processing facility here. It's going to be the first in the world in terms of their production capacity, which is basically offered by Renaissance Company. And Udakan, another part of the Power of Siberia. In Murmansk region, we have the project for local shipyards. So this is the KAMAZ-based crane, which uses 8x8 chassis with the Cummins diesel. That is basically the main drivetrain for also frac job fleet and CT fleet. And we saw this 8x8 chassis is suboptimal in terms of their permitted load per axle, because it can only bear 15.5 tons, while usually the units are in excess of 20 tons. And to accommodate for that kind of load, we now offering the 10x10 chassis, which is road legal. So this is the 20-ton manifold with the Cummins ISL 485 engine. So this is the chassis that we compared to our foreign competitors, and which means that we perform just as well in terms of the technical capacity. And we see this chassis as the primary bearing vehicle for different coil tubing and fracturing units. We also produced dedicated 8x8 chassis with a new cabin with a 500 horsepower diesel Cummins engine, also road legal. Well, technically, it can carry up to 30 tons. Once again, this chassis is much better in terms of serviceability and maintenance for potential clients than anything that's important. So these are the previous results of our work. So the second objective for us was to use our chassis together with the Packer company, or the Packer service company. We have refitted the CT units and frac units that they had previously running on Mercedes chassis to re-equip the KAMAZ chassis with the units that they have. I don't think that the foreign producer is going to give us any preferences or benefits in terms of the welded equipment. Also, this is the first batch of 23 cubic meter bearing water tankers. So that basically replaces 2 standard road-going tankers. Right now, we are developing a project to produce the gas tanker, 4,700 liters capacity in place of 3,000 liters capacity, running on a standard chassis. I'm sure that Gazprom production facility should have vehicles like this in every site of their operation. And the Huderified saddle trailer, KAMAZ Batyr, can be equipped for operation in all extreme conditions. Furthermore, I would like to draw your attention that service of our vehicles is offered by all service stations, by KAMAZ stations, and our support areas are in Urengoy, Nizhnevartovsk, and Surgut, and Syktyvkar, and etc. So you're not going to end up with no service and maintenance, even if something breaks down. That's it. Thank you.
Спасибо.
So we're import substituting.
Вопросы у кого-нибудь есть?
Any questions?
Спасибо, Евгений Анатольевич. Прямых вопросов
Thank you.
нет.
I guess that we don't have any questions. Dear colleagues, thank you for bearing with us. Just a few more minutes. Tom wanted to tell us a few housekeeping issues about the conference, and with that, we're all released.
Сегодняшний день, он был очень насыщенный, как онлайн, так и офлайн. Много докладов было, все доклады интересные. Спасибо большое всем. Вот. Завтра в 10 часов начало конференции, первая сессия открывается в 10. А сейчас предлагаю вам пройти на ужин. Ужин будет у нас в соседнем зале, вот, то есть в формате фуршета. И прошу не забывать также про журнал, так как конференций мало, а журнал наш «Время колтубинга» может быть площадкой для обмена мнений в онлайне и в офлайне. Спасибо большое. И дам председателю ICoTA еще слово сказать, Константину Бурдину.
Друзья, спасибо огромное прежде всего организаторам, всей команде, которая обеспечила сегодня бесперебойную работу, докладчикам за интересные, уникальные доклады, которые были озвучены сегодня и завтра еще продолжатся у нас. Вот, ну, всем спасибо.
Thank all the presenters, all the members, all the organizers, and with that, I wish you a good day.